We're going to prove the derivative we're going to derive the formula for the derivative of ln of x. For one of the things we have to know first is that the limit as n approaches 0 of 1 plus n to the reciprocal of n is defined to be the number e. That's the number e. Okay, so whenever we have this, we have e. So now let's go and try to derive this formula. Let's first state it as a theorem. If f of x is equal to ln of x, then f prime of x is equal to 1 over x. And the proof is going to come from the definition of derivative and logarithms. F prime of x is equal to the limit as h goes to 0 of, well, f of anything is just the ln of anything. But I didn't need to say that just yet. It's f of x plus h minus f of x all over h equals the limit as h goes to 0. Well, f of anything is just the ln of the anything minus f for something else. So it's ln of that something else all over h. Now limits have a number of properties. Ln of one thing minus ln of another thing is ln of the first thing divided by the second all over h. Now let's just clean that up a little bit by doing some division. X over x is 1 plus h over x, all divided by h. Now, ln being a continuous function, which you'll learn about in advanced calculus, you can bring continuous functions in front of the limits. So this is ln of the limit. The limit is h goes to 0 of 1 plus h over x over h. And maybe that was premature to do. I apologize. Dividing by h is the same as multiplying by 1 over h. So this is 1 over h times this ln. Now, ln has a property, or any log has a property that the multiple can go up as the exponent. So this is ln of 1 plus h over x to the 1 over h. And now I will invoke that advanced rule that says you can bring the ln in front. It's the ln of the limit as h goes to 0 of 1 plus h over x to the 1 over h. Now, if you look at that limit, this piece, it's starting to look like e. For example, if we had x over h, then we have the limit as h goes to 0 of 1 plus something, which is going to the 0. The h over x is going to 0, raised to the reciprocal. But we don't have that x. So somehow we just have to get it to be an x. Well, if I raise this to the x, and then I raise it to the 1 over x, those x's pretty much cancel out. So then I get ln of the limit as h goes to 0 of 1 plus h over x. Now I get to multiply those, and I get x over h raised to the 1 over x. raised to the 1 over x. Now we're going to invoke another limit rule. Since this has nothing to do with x. Sorry, with h. So we still have the ln. What we can do is first take the limit. And then raise it to the 1 over x. So this is equal to ln of the limit raised to the 1 over x. But this limit is e. And then we invoke the reverse rule that we did earlier. You can bring powers down in front. So now we have 1 over x times ln of e. But ln of e is 1. So we have 1 over x times 1, which is 1 over x. The derivative of ln of x is 1 over x. Not because the teacher told you, not because I told you, but because he rigorously proved it.